Great. Thanks,
Hey,
all.
I'm Lester from AGU. Welcome to our workshop with National Geographic today. I'm just here as the tech. The team is going to introduce themselves and their project, and you can, interrupt them and ask questions if you want. This is a workshop. It's supposed to be informal, and this recording is just sort of for lessons purposes. We're not live streaming at the moment. It's for archival. And I'll turn it over to the National Geographic team.
Thank you. Thank you. Lisa, right? Liza. Okay, thank you, Liza. My name is Paul Umulo. I am a Senior Director of Storytelling Programs with National Geographic Society, and I'm happy to welcome you to this workshop, World Water Map Insights, diving deeper into water journalism. As Liza said, it's a workshop, so we intend for it to be very interactive. And I want to start by introducing my colleagues that are here with me, some of our explorers and also colleagues and partners that are here. So we have Mark Perkins. Mark is right here. Mark is a National Geographic explorer and professor of hydrology at Utrecht University. And then next to me, we have Nico Wonders. Nico is associate professor of hydrological extremes, a very cool title at Utrecht University. As you can see, Utrecht is our partners for this World Water Map. Then we have Sean Breyer. Sean is from Esri, and then the one that do most of the technical lifting for the maps for us. And then I will have Alex Tate. Alex Tate is a geographer for National Geographic Society. And you're going to hear from each of them by the time we're done with this workshop. Okay. So our goal today is to really get hands-on experience on the World Water Map, insights and its enhanced data capabilities. I'm sure some of you have used our original World Water Map that was put out about a year and a half ago. So this one goes deeper on the data and gives you the opportunity to be able to actually do a lot of work and modeling with the data. And then, so we want you to be able to understand these applications to reporting on water issues at the global, country, watershed, water province, and hyperlocal level. I'm sure most of you here are journalists, so you're interested in the reporting capabilities, so we can be able to walk you through how you can do that. And then learn how to create visuals and animations to accompany your stories. We all live in a multimedia age now where you need visuals, you need all those cool things to make the stories exciting. Is not back in the days when we just used to read. Now we read and we watch. So this provides you the opportunity to be able to do a very robust story. Next slide, please, Alex. Okay, so just a quick background on the World Freshwater Initiative. It's an initiative that the National Geographic Society started last year, 2 years ago, actually. And the goal of the initiative was to really better understand water usage around the world. Water is one of those resources that we don't think about it until we have issues with water. So at National Geographic, our goal is to start making us think about water, especially looking at how we're using water and when we are beginning to use more than we regenerate. So that's what the World Freshwater Initiative is. And there are two components to this initiative. First one is the World Water Map, which is why we're here today. Again, we launched the public version of the map last year during the International Water Day, and it's been used by so many people to be able to have an understanding visually of water usage around the world. And then today we're launching the Insights version, which is the expert version that allows you to be able to dig deeper and get more insights in water usage. Besides the maps, we also are making grants. We have been funding grantees, our storytellers and explorers, on storytelling to use data from the map to tell stories. The whole idea is that by telling these stories, you can actually be able to humanize that data. Most of us are not researchers, we're not scientists, so we look at data and it just goes over our head. However, when you can take that data and tell a story and humanize it, then people can be able to really understand the challenges that we're facing. So we've given, since last year, 15 storytelling grants to filmmakers, journalists, photographers around the world that are really doing amazing work. We've also given grants in conservation and science. We did 4 of those grants this year to organizations that are involved in science that are looking at how they can be able to use science as a way to conserve water. So these two are going side by side. Next slide. So again, the goal here is that we want data to be able to meet story for journalists. So you can be able to, again, look at how in your reporting about water issues around the world, you have access to data, you have access to visuals, you can be able to dig deeper, and you can be able to, again, bring these issues to where they become very, very important to your audience. And that is our goal here. So on the left, we have two of the grantees we funded that use data from these maps to tell their stories. On the top is Aika. Aika is a filmmaker from Tanzania, from Dar es Salaam, and she has done a documentary that looks at the city of Dar es Salaam and how urbanization has basically dried up the lakes. Dar es Salaam was a city surrounded by many lakes. And over the years, because of urbanization, they basically sand-filled all the lakes, and they're building all these massive buildings there, and it's having an impact on water supply in Dar es Salaam. Then we have Caitlin. Caitlin is a photojournalist that again has done a very amazing photographic essay about the Colorado River Basin. And I'm sure most of you in the US have heard about the fluctuations of the water levels in the river basin and how it's having an impact on the farmers and all the people that rely on this river basin to be able to do their work. And that's, again, where a lot of the agricultural outputs from the US come from. So again, what they've done is that they've used this data to be able to show us the impact of water usage and water shortage. So I'm going to hand over to my colleague, Alex, to give us a demo of the world water mapping. Thanks, Alex.
Thanks, Paul. And as Paul said, this World Water Map Insights tool is really an extension of the original World Water Map, which was for a general audience to start understanding water scarcity, understand what the water gap is, where demand exceeds renewable supply. And what we're going to be able to explore are the different geographic scales that you can explore through the map, and different attributes. So we're talking about water gap, but that's built out of demand and withdrawal, and getting an understanding of these different attributes of global water accounting. And it is a global data set. It's a modeled global data set. And we can look at 1980 to present, and then we have projections into the future. And that's one of the key things that has been added to this version, and really gives you insights into what is going on, what has been going on, and what could potentially be going on under different scenarios. So let's dive into the map. I'm going to do a live demo here, and hopefully we're all set up so that I'm going into the browser. And this is the site. It works on tablets, it works on computers and mobile phones. We've worked very hard with our partner Esri. Sean's here from Esri to make sure it's very performant, it's very quick, so you can get information out of it quickly and then start looking at very specific examples. So we've given a couple of case studies here to start with, if you just want to get an idea of the sort of information you get comes out, but we're going to dive straight in, and we are going to, I gotta get my mouse over there. Which side of the screen is it going?
Yeah.
Okay, there we go. Open Data Explorer. Oh, it's gonna be nice and big. So you jump straight into the map and you get information right away about what is the overall water gap in 2019. And you can look at it by sector in these bar charts here. And then you get a graph of the entire time period for historical information. And as you move around the map, you can fully pan and zoom. Let's try this. There we go. And the table will update with the country with the largest water gap will be at the top. And you can explore the map through either selecting from the table here, or you can go straight into the map, and we're going to pick Brazil and take a look at the total water gap for Brazil is highlighted here with some summary information. So very quickly you get a picture of what is going on in Brazil. But we want to be able to do a little more exploration, so we can go up to these blue buttons at the top. And let's actually take a look at water demand for domestic. And let's change the geography to look at water provinces. And now we see for South America and for Brazil, areas where domestic demand is the highest. We can take a look at the area around Sao Paulo, by clicking on that water province, and now we have regional watersheds within this water province for Sao Paulo. So very quickly, and we can use the zoom button for this watershed with the greatest demand. And we zoom into that watershed at a regional watershed level. And then we can actually dive all the way into a very localized watershed in central Sao Paulo. Again, looking at the water demand for this area. We can, of course, switch to look at the total water gap. And then we get a different statistic here. It's a nice little geographic trail we have here, so we can go back up to Sao Paulo at the water province level. And we can take a look, and we'll take a look at the projected water gap for 3 different scenarios. These are scenarios that have been used for the International Panel for Climate Change. And we can take a look at, for a sustainable scenario, where we're doing some sustainable means for mitigating climate change. We can take a look at what is going to be happening to the water gap. So now we have the past water gap and we have the future water gap. And there's variability, of course. And one of the very handy tools that we've built into this website is the ability to compare. So we can see that for this area around Sao Paulo, the water gap is projected to increase 21% under this scenario. So even if we address some of the effects of climate change, there will be an increase. We can follow our trail back out to Brazil, and we can see that for all of Brazil, there's going to be a change of 12% increase in the water gap. And so that's demand that's going to be evident that is not being able to be met by sustainable renewal. You can see the symbols are pretty small, but for every one of these geographic levels, you can then download a set of data. And this is where data journalists and people that can work with an Excel table, it's going to be a CSV file that you can bring in. And there's going to be geotiffs for every one of the variables at that level of geography, so that for each year, you could then build an animation or another way of visualizing this data beyond what we've done here. This is really just a sample of how you can visualize. There'll be a lot of ability to visualize with this downloaded data set. Can we see the cancel? Oh, there it is. And then another really handy feature is that you can, there it is. There's a little camera icon here, so you can do a quick capture of the map or a capture of the graph for that area. So these are ways that you can explore data anywhere in the world. And again, the tool is very quick. We can take a look at California. So we switch to the United States. Take a look at the water provinces. And we'll see, again, right now we're on the compare, so we can see areas that are projected to have demands on the water into the future under this scenario. So we can pick, it's interesting to me that Wisconsin is showing up as an area where there's going to be increased water demand that's going to be unmet. So you can sort of discover stories that may not be obvious to begin with. All right, I think that's a good demonstration of the sort of things you can do in the tool. So I will go back to the presentation to the right. There we go. There we go. That's us, live demo. There's a QR code if you want to try it on your phone, your tablet. livingatlas.arcgis.com/WWM. And I'll let Paul close us out. Actually, I think we're ready for.
No, I think we have, next slide, please. I think we have.
There we go.
Yeah. So explore the water gap in your region if you can. You want to take a few minutes to explore. Explore the compare mode. What does water availability look like in 2050 compared to 2020 in any particular area you choose to explore? and what is driving any changes you observe. Is it agriculture? Is it domestic? Is it industrial? And if you can generate a map that tells a water story in your area of interest. If you want to take, 2 minutes to do that, 2-3 minutes to quickly do that, and just to test drive this yourself.
Or if you want, we could go back to the map. If you cover a certain area or then if you want us.
Question, can we distinguish surface water and also groundwater demand and what's happening to the groundwater, actually to the aquifers in different parts of the world through this map?
Yes.
Scientists.
So basically, another feature that is not interactive yet, but it is in the downloads, in the data,
Okay.
is the water balance of each catchment, and that includes how precipitation is divided into evaporation, discharge, and storage loss. So that's an indication. And there's also the how water demand is or how water withdrawal is divided into renewable and non-renewable water withdrawal. And if you take a non-renewable groundwater withdrawal, you basically get your groundwater depletion.
Yes.
So that's also part of the downloads, but it's not part of the interaction yet. So that's something that we will add to it, so that you can see for water provinces or catchments where groundwater is actually lost.
Right.
So
not in this setup.
Not in the setup that we have now, but it is in the downloads. So you can get maps or time series of non-renewable groundwater withdrawal. That means actually groundwater taken permanently out of storage, and that is actually depletion of groundwater.
And this would be based on official data.
No, all these data are based on model simulations with a global water model. The name is Specia Glob, WB, that's the model. That's the one that we in Utrecht University built.
Right.
And that also simulates the different sources of water for the different sectors. And one of them is surface water, groundwater, and also non-renewable groundwater.
Just to understand it better, because let's say a government says that our deficit is 70 cubic kilometers.
Yeah.
But then the scientists are saying that it's 150.
Yeah.
And then it's hard to find the correct data in that country that's not democratic. So
that's the thing. Some people,
the grace of grace.
Yeah. So one of the things we have done is we compare our model results with GRACE, for instance, to see where the storage loss that we simulate based on groundwater depletion, whether that fits a bit fits the GRACE data. And well, we generally get a pretty good match with our model with these data. So generally non-renewable groundwater use or groundwater depletion is not reported. If you go to the Aquastat 5-year statistics, they say groundwater withdrawal and they say surface water withdrawal, but not what is renewable and not. So to get some insight into that, which part of the withdrawal is actually supported by rainfall and recharge, and which is actually taking it permanently out of storage, this is a pretty good source to go to. But of course, it's a model, and any model has its uncertainties, as you know. Yeah.
We also have a few additional slides if you are interested in understanding what went into calculating the water cap.
Yeah.
Let's go back to the PowerPoint, please. Okay, next. So besides the insight tool, we already have an existing world water map that is more for the public usage. That one is out there and is being used today. We also have a map maker world water map, which is targeted towards students and educators that again brings these issues down for younger people to be able to understand water shortage issues around the world. So this again is a very robust initiative that National Geographic is supporting. And this is just, again, the third iteration of the map of what we're doing today. Next slide. Okay, so we have these are sessions. We have other sessions exploring water scarcity dynamics. I think the exhibition hall is closed, so you can't visit our exhibition hall anymore. But again, do stay in touch with us. Next slide. For press inquiries, Steph Miseli is our press contact person for the initiative. So please make sure that you reach out to Steph if you want to interview any of our staff or explorers working to understand more of the data behind this. Steph can be able to arrange an interview for you to speak to our explorers, also to speak to our grantees that are doing work and telling stories about this. If you want to get more additional data on where they're working and what they're doing, please reach out to Steph, and Steph can be able to give you that information. So if you can also highlight the work that they do. And then, visit the natgeo.org freshwater, which is a launch-off point for the initiative. So you can see launch up to the insights map and also to the existing map already. And then the Living Atlas is where the insights map is housed at this point. So that's a URL. Visit it. So.
And then after that, there was a slide to address your question about the water gap.
Okay.
Yeah, okay, this basically shows what type of information goes into such a model to calculate water supply and also water availability and water demand and water withdrawal. That's what we do. So there's not only on the meteorological data on top and all kinds of data about the land surface on the left, but there's also all kinds of socio-economic data on the right on where water is being used, where people are living, where the factories are, where the dams are located, where there's irrigation going on, and all those things come together in a model that calculates. Yeah, you can maybe just quickly go through. That basically tells you how this is basically the sort of output that we generate, and from that we can calculate the water supply and the water demand. So the water gap is calculated by taking the water demands and subtracting the withdrawal. So a certain sector, think about domestic or irrigation, they want a certain amount of water. And then they find that either in ground or surface water or reservoirs in the surrounding, but there's not always sufficient enough water. So they take what they can get. But sometimes they take not only what is in the surface water and in the renewable part of the groundwater, but they also take groundwater that is deeper and that basically is not being replenished anymore. So we have to correct for that. So if you think about the water gap, that's really only the gap between what we want in water and what is renewably withdrawn. And the rest is the gap. That's the part that causes groundwater depletion. And there's often also an unmet demand. You can, for instance, think about the Ogallala aquifer, for instance. They have a certain water demand. They extract some from surface water and some from renewable groundwater, but some from deeper non-renewable groundwater. And still, they may have a shortage because they don't have the pumping capacity to fill the whole gap. And there's always a little bit of unmet demand left. So this is how it's built up, and these things are all reported. And this is the part, basically, this part this is what leaves your aquifers depleted, this part of the water gap.
Question.
Yes.
So whenever we have all these aquifer depletions, we usually also have land subsidence.
Yes.
And then with that all together, we have mass migration in many parts.
Ah.
Something that we are seeing in different parts of Iran right now, so
Okay.
to speak. So how can we put all these together? It can, let's say, a study of water demand, depletion of aquifers, and then migration that happens. Couldn't be that something that be helpful for reporters to understand that better
Yes,
about the
certainly.
impact, social
So-
impact?
So this is why we have the hotspots. We have these hotspots, maybe we have I think we have a map. Are
Is
they,
there
are they,
hotspots
are
map
they,
in here?
I think the slide of the hotspots, have you added them, Stephanie?
Don't have that here, but I can follow up with you after.
There's a slide, we basically have hotspots where we do deep dives. We also have a PhD student that's looking at those. And I think Iran is one of the hotspots as well. And where we really look more into detail about the socio-economic drivers behind groundwater depletion, for instance. But also what measures are being taken, what the impacts are. We're using a drivers pressures impact framework to do that. And land subsidence is certainly one of the things that we look at. And there's also the storytelling grant. So if there is someone that would be interesting to report on this exact issue, they can try submit a proposal for a grant. And then with these data that we have, and also the scientific work that we do on these hotspots, in your back pocket, you can go over there and try to report how people are
No, I
really
can't,
dealing with
they'll kill me, but no,
it. Well, anyway, yeah, okay, but that would
literally.
I mean, literally, I know, but I mean, this is a possibility for safer places
Yes.
where you want to report on these things.
In a parallel goes.
Yeah, thanks for that reminder, Mark. We also have a new round of grant making that's ongoing now that we have on our website on the freshwater initiative. So if you have, ideas for story ideas, or you have people that you want to encourage to look at it and apply, please. We're open till April 31st is the deadline next year, so there's still some time. You can just go to our website or reach out to Stefan. We'll share the link with you. So you can, spread the word around, journalists or filmmakers or other storytellers, because these are, again, looking at stories about water. And one of the things we also try to encourage is that we're not just telling the stories about the doom and the gloom. We also want to tell stories about the possibilities. We want to tell stories about who is doing something to address this issue of water depletion, for example. One of the science grants we funded this year is looking at fog capture. Basically, the technology to capture fog as a way to replace water, to see how realistic it is and how we can be able to use that in different places as a way to increase, the water source. So we are looking at, stories that tell what's going on, but also stories that bring hope that we can be able to actually do something to change the situation.
And if you're interested in more the technical aspects and what you could actually do with the data, Sean has a few.
Yeah. We're gonna go through this quickly.
Yeah, that's.
So we talked about part of this is a walkaway as you get this download file collection. And this is really for whatever target area you pick, you can download the entire data collection. That includes things that are not even in the display tool. So we were mentioning water balance and some of these non-renewable versus renewable groundwater. All that data set is available in this download collection. And one of the reasons we do that is there's a huge collection of files behind here for each one of these. So once you've got the download, it'll be sort of easy. It's a zip file that you can unpack on your desktop, and it's going to have a series of comma separated files that already have summaries of each one of the variables that are ready to be used to do graphing. But we also have this raster data collection. So if you have a data analyst on your team, they'll be able to use GIS software like we have or some other software very quickly, take any two layers and lay them on top of each other and do some real quick analysis. So let's go. So here's one where I actually just took some of those comma separated files. I took the gap, the demand, the total withdrawal, and the non-renewable extractions, which is the groundwater, and put them all into this Excel spreadsheet together. Did a real quick set of calculations and created The actual model that he was just showing you.
Yeah,
Is the water gap is that red section at the top, but you can see the blues are the groundwater and the renewable surface water. So we can put those all in the graph together very simply. So this is another way you can get access to some deeper information. The other was just doing some simple graphs on one variable, like we were seeing in the app itself, just total water gap. And then if we go forward one more, so this is sort of that GIS component here. What I did is I actually took a map from 1980 of California, where you can sort of see here. In LA, we've got a lot of water gap, but then you can also see sort of through the Central Valley. You can see it slightly, but it's very hard to see. We moved to this is 2019. We see this including more in the LA area as it's been growing, but we also sort of see an increase here, but it's still pretty hard to tell. So I just actually subtracted one from the other, and it created a change map for us over that period. And now we can start to look at the hotspots. The same map that we were talking about that Nico's built is now we can start to see how much more of an impact water gap is in the LA area. But we can also see these areas of success where the blue is improvements in the gap over that time frame. And we can start to see breakdown. So we know that this is all domestic related because it's an urban built up area. But out here, we actually know this is all agriculture. So we can actually start to split across the reasons for that. And then we can bring in the data layer like we were looking at before that non-renewable groundwater. And if we laid that into this and subtracted it from here, you would start to see this one show up more as an effect from non-renewable water. So just some simple ways to take the data itself and start to explore it in new ways with your data science group.
So like, let's say, southeast of Fresno, when we get to Corcoran, and where you have the biggest amount of land subsidence in the US. How do you compare them? Can you show any comparison on the map right now?
I don't have anything set up, but it would just be taking that same data set
Right.
and adding in one more data layer, which is actually the extraction for non-renewable water. Adding this into that would show the intensity of where that is happening compared to somewhere like LA.
Right.
Where there's no groundwater abstraction happening. It's all coming from remote sources.
Yeah.
So that's the two of those layers combined would be the right map.
And I think just looking at this map as a journalist, you can definitely start getting ideas, what stories you can tell. If I look at the blue section in the top map now, a good story will be what has happened in those areas that have led to some improvements. If you just look at this now, those three maps, you can say, okay, maybe we do a deeper dive on, why. So we can be able to replicate that in other communities where we want to see progress.
You're feeling adventurous, you can have a volunteer if you wanna look up your own watershed or area of interest too.
Well, I'd like to understand the kind of story that I could tell. I had a look at where I live and I have a plus 4,362% and a minus 80%, one after the other. And seriously, I don't know what explains that. So if you want to try.
Sure, we can take a look at it.
So it's on like the northern shore of the Gulf of St. Lawrence in Quebec,
Yeah, if you've got
Canada.
a city name, you can actually just type it in at the top. We also have a search tool, so you can discover by cities and it'll zoom into that.
Okay.
first.
Sitting in?
Try Anticosti, Anticosti Island.
Say this.
Yeah, that's the first one. So right north of it, you have like this section just on the right of the one that's highlighted, that one that's kind of triangle and that touches the shore. It's plus 400%, 4,000.
And then you go to that low one,
This one,
that one. I think that one.
yeah, exactly.
That one.
Yeah.
Click on it, additional. Yeah. Yeah, this is so, there's hardly any water use there. I mean, this is, or any water gap, so. So you're basically comparing zero, so.
Yeah, but how come I get plus 4,000, plus 4,000 and you get 0? Is it because I
What are
didn't,
you looking at?
I'm looking at the total,
Oh, you're looking at the total water gap?
yeah,
Okay, yeah, you're bag. Yeah,
it's just because of
Small
lack of
numbers.
data, I suppose.
No, you have like
And Trudeau hasn't discovered there yet.
Exactly. Know what I mean?
No, that's the thing, so we
the
have.
numbers are so small.
That's a
that
good point.
If you go on the right side, you see some minor improvement in the industrial water use, but that bumps it up so high. That you get, that's because your starting point is all close to 0.
Yeah.
So the percentages are kind of,
So there's no story.
yeah, unfortunately, or fortunately.
No, but it's a good thing that you pointed out, but this is something we have to probably, how do you call it, capture. If
Yeah.
thing is, if there's nothing going on in terms of,
People
human
need
water
to be
use.
able to
Or
understand
water
that.
gap,
yes.
yeah, then percentages should not be shown, because it's
Yeah.
basically, it's basically dividing by 0, that's what you
Yeah.
do.
So
This is why you
Sean
get
and I are
this high.
taking notes. We want to flag for people with some clues about what may be going on.
Yeah,
So that
because-
when numbers are very small to start,
It
or
becomes a fake news
Yeah.
factory.
Yeah, exactly.
we don't want that.
May I ask if you could discover Tehran over here?
Yeah, you're testing the geographer's spelling ability and he succeeded.
Okay. So based on the data you have, what's going on here? Let's just, whatever.
Well, what you see an increasing trend over time, so this is the historical part, so going from 1980 to 2019, we're not looking at any of the climate projections just yet. But you see increases in mostly irrigation water demand, going up from, the numbers are on the bottom, like on the right here.
Yeah.
But for most of them, increasing by 50%.
And domestic as well.
Yeah, increasing by 50%. So that means that indeed there's way more irrigational water demand being done here. So that's what you see on this map here.
Which feature do you want to look at?
You can take the
The middle one.
actually not that bad.
You see some, you see some a little bit of increase, but not really, not much. But some.
So based on this, can you have a forecast for the future? I'm not asking about when would be the downfall of the Iranian regime, like what happened in Syria, but just based on this, what can we understand what could possibly be happening in the near future?
Well, for example, you can compare like the different climate scenarios. So in terms of like what happens if different pathways are taken, because you also see the yellow, the orange and the red bar on the right side that indicate if you follow different climate trajectories, what is going to happen in this water gap for the vicinity of Tehran. So that will be a starting point. And I would actually be interested also to try a little bit deeper, like looking at the individual components, like which kind of sector is then driving that increase or decrease. Like is it irrigation or is it indeed industrial or domestic water use? Because that also tells you something about potential solutions that you could seek to mitigate that gap. Because if it's all on irrigation, then clearly you have to look at your agricultural practices. If it's domestic, then you have to look at your domestic sources for water. So that is the information you can get out of this. And with the data download, indeed, you get also to have to explore the different and put these lines next to each other because now they're in bars, but of course you can also plot them as CSVs in one Excel graph or something more fancy than that. And we don't do the projections for this one.
Not yet, well, we do them in the downloads, but not yet in the tool itself. That will be later.
So that I think that informs you really about what is driving that water gap there and what kind of projections you can
But we
anticipate.
must be honest when it comes to projections. This is basically So the past is reconstructed based on reported data of socioeconomic data on population and land use and extension of irrigated agriculture and urbanization. But of course, in the future, these are projections coming out of integrated assessment models that are also used to calculate the emission scenarios for the IPCC, the same type of information we use. And of course, these are projections not for nothing, they're scenarios. They're not an actual future, but they're a possible future under assumption of a certain storyline on how the future would evolve. So it's very, you have to take them really with care. They are scenarios, right? And they're not actual futures that would evolve. No actual future would follow an actual scenario. It is basically a storyline on how the future could evolve. That's something to remember always if you look at these things. Yeah. But especially if you have irrigation and you're in a region where rainfall will decrease tremendously and most of the climate models are agreeing on that, then you could sort of be quite certain that what's going to happen there is rather realistic, because there is because changes in temperature and rainfall drive irrigation, how much you need for irrigation.
Thank you.
Great. Okay, thank you so much. I think we're Steph, what's our time?
Yeah, please, that we have watershed. Yeah.
Maybe what's to come is that, do you have the slide or not? That's what you end with.
It's looking kind of blank.
Go to the right side again.
Yeah.
Oh, but it is blank, yeah, so,
It used to have some text on there. We do have things coming soon. Sean and I are gonna be working on getting more things into the visualization. I think the sector parts of the future scenarios are important, so you can see the difference between domestic, industrial, and agricultural demands. We are going to be, what else do we have on that list?
Be a report.
And then we're gonna be able to provide a sort of an auto-generated report, so you get a PDF with the map, the main graph for that geographic unit, and then some generated text with some basic statistics, summary statistics that are exposed through the map. And you can just hit the download, so if you want, a certain water province, if you want California, area around Tehran, areas in Canada, you'd be able to get a report, or a country level.
Wow.
And there's gonna be tutorials.
And we're gonna generate a few tutorials, so things like what Sean was showing with the simple graphing through Excel process, basic GIS comparisons. Maybe one where we show how to bring the geotiffs into an animation, so you can see an animation through time. So we're gonna do some tutorials that'll be on the website as well.
Well, thank you everyone for coming, and thanks.
Thank you. Thanks.
Nadia and their friends for this great presentation.
Yeah.
Don't forget your
Thank you.
contacts.
Okay. Actually, there's a weekly show about water. Both encouraging.
I don't speak Persian.
I know.
I don't speak Farsi. That's
Yeah.
what it is.